Today we're going to be talking about zero trust security, and it's called From Airports to Identity-Aware Proxies. I don't have a clicker, I'm old school with the keyboard. So a bit about me, I'm a developer advocate at a company called Pomerium. We're a zero trust security solution for context-defined access to secure your internal apps. I'm from Montreal, Quebec, Canada, so came across the ocean to hang out with all of you. And I'm Nicky T online pretty much everywhere. And these are all the places you can find me at nickyt.online. And feel free to grab the QR code. If not, it's at the end too. So what are we going to cover? We're going to talk about why zero trust matters, the problem with perimeter-based security, and airport security as a zero trust model. And then we're going to go into the core concepts of zero trust, like the identity-aware proxy, context-defined access, policy engine, microsegmentation. And then we're going to look at the benefits of zero trust for legacy systems. And then we're going to talk a bit about an implementation path. And also, since it's KubeCon, zero trust and Kubernetes play well together. And then we'll just go over some key takeaways. So before we get into things, a bit of my background. I've literally been an application developer my entire career. I've led front end at a bunch of teams and stuff. And so like infra and security is pretty new to me. So hopefully I have a fresh perspective of what we're going to go through here. And some people might be looking at me like I'm crazy that I went from doing front end to infra and security, but YOLO. I did work at Netlify as well, but not on the infrastructure level. I worked on the frameworks team, so it was still at the software level, not so much infra. So why does zero trust matter? There's a changing landscape happening. There's microservices and cloud services. They all expose more endpoints. APIs are accessible from anywhere now, so it increases the attack surface. And also, traditional perimeter security doesn't fit the modern deployment model. Also, security decisions move outside of application code with zero trust. You end up with consistent access patterns, and also there's no custom security code to maintain within your app logic. And also, security is a shared responsibility. It also moves it earlier into the development process, and also developers implement auth patterns, not just security teams. So what's the problem with perimeter-based security? So imagine showing your ID once at the airport security, then being allowed to board a plane, enter the cockpit, or access the control tower. Sounds a little crazy. And also, if anybody are fans of Foo Fighters, this is from the Learning to Fly video. The reality with perimeter-based security is it operates exactly like this. Check once and then trust forever. Yeah, sorry, I couldn't resist that meme. It's a classic. Also, there's remote work. People have personal devices now. There's cloud apps that expose the limitations of perimeter-based VPNs. Also, to be clear, this talk is not meant to be bashing VPNs. I'm just trying to state objective facts here. So what is the fatal flaw as well? Perimeter-based security assumed that the threats were outside your network, and the reality is they're probably in your network as well now. And we've all heard about like state actors being in networks. So basically, perimeter-based security has some issues. There's some alarming statistics. This is from a recent Bleeping Computer article. There was just like 2.8 million unique IP addresses actively attacking VPN infrastructure worldwide, which is wild. And the thing with perimeter-based security is once somebody compromises your VPN, basically your network is compromised or potentially compromised. The other thing too is VPNs create a secure tunnel, but then they trust everything inside it. Now, you might say, okay, but there's like next-gen VPNs and there's like more things in place that can help with that. And that's true. You can have like multi-factor authentication. But the thing is, even with that extra layer, you still end up with the same problem at the end of the day once you're in. You're just completely trusted. And if you want to think of it in the context of an airport, think of MFA as like you do a retinal scan or something, but you're only checked once and then you're in. And the other thing is, again, like I was saying, even with MFA, once you're in the network, there's nothing stopping people from moving around laterally within the network. So Let's talk a bit about airport security model for in the context of zero trust. Also, I'll make the same joke I made in somebody's talk yesterday. I'll be hosting a Peloton cycling course tomorrow, or after this. Sorry, this headband's cracking me up. Okay, so yeah, if we talk about zero trust in the context of airports, you have multiple verification points. So think about initially, you get your ID checked at the entrance, maybe you get your boarding pass, and then you got to go through security screening, and then there's also your boarding pass. And these things all basically map to zero trust principles. You're initially getting authenticated. There's device posture verification. So think of that, bringing your bags through security. That's the same thing like, hey, can Daniel be on his phone if he's accessing prod? I don't know. We'll see. Other things, so you have like gate agent checks. So that's just in time access validation. Boarding the plane is like accessing an application. Cockpit access is like privileged access. And here's a little, I actually made this with, I don't know if anybody's used bolt.new for, maybe you have, Daniel, because you've done a lot of front end as well, but I generated this with AI, so it's using some web tech. But basically the point here is every time you go to somewhere else in the airport, you're being verified again. Just doing a quick time check here. So let's talk about movies, since we are in a movie theater. And there's a movie that came out, I believe it was in the early 2000s, called Catch Me If You Can. And it's with Leonardo DiCaprio and Tom Hanks. And essentially, it's the true story of somebody called Frank Abagnale Jr., who's played by Leonardo DiCaprio. And Tom Hanks is, I believe, the FBI agent that's chasing him the whole time. And basically, what Frank did was he exploited trust-based systems by impersonating pilots and other professionals. And his technique was simple: obtain uniforms, fake credentials, and then just gain access to planes. He literally flew around the world. He would sit in the cockpit just to take a ride. He didn't fly the planes, but he'd be like, oh yeah, no, I'm not flying this one, but I don't know, I'm going to Tokyo, I have a flight over there. So literally flew around the world for free, duping everybody. And the thing with this is it's the security failure of the perimeter-based security. Once your identity was assumed, there was no further verification that occurred. And I actually just realized that is Tom Hanks in this animated GIF, but as a pilot, not as the FBI agent. Anyways, so why did this work? Like I said, it relied on perimeter-based security, so think the uniform, rather than continuous verification. There was no contextual verification, like he wasn't on the flight schedule, nobody checked that. There was no verification of his credentials, like his experience. And there was no separation between basic access, like boarding the plane. Like nobody just questioned him. He's got a pilot's uniform on. He must work for an airline, so don't question him, basically. And he also got privileged access to the cockpit because of the uniform. And there was just no continuous monitoring of suspicious behavior patterns. And I'm going to read this quote because I think it's really good. And this is from, I encourage people to check this out. There's a link in the resources too, but it's a talk that Frank Abagnale gave at Google Talks, and it just talks about basically the whole premise of that movie. And what he said was, all I saw was this uniform, and I said to myself, if I had that uniform on and I walked into a bank, it'd be a lot easier to cash a check than me walking in as just some young kid. So the whole thing was to get that uniform and do that. So let's talk about a key principle about zero trust. Never trust, always verify. And I'm going to keep going through analogies with the airport. Partially, I'm trying to solidify my own knowledge of this because I'm still new to the role. Hopefully this resonates with people too. So think of the public internet as like you just get to the airport. You haven't even gone through any security, so it's an untrusted zone. There's an identity-aware proxy, which we'll talk about shortly. Think of that as like the entire airport system managing all the verification points. And there's also something in identity-aware proxy that we'll talk about as well shortly, a policy engine. But think of these policy evaluations as like the security checkpoints, the gate checks, the boarding verification. And think of applications as like the actual planes. So people boarding the plane once they have their gate. So think of that as your access to a particular app. And then there's stuff like admin privileged access, so getting access to the cockpit, and that requires additional verification. And that's something in zero trust and in security called privileged access management. And the other main thing, and alluded to this about nobody was checking Frank, is just continuous verification. Get through that first point. Are you the pilot? Can I see your license again? Oh, you're trying to get on the plane? Can I see your license again? And none of that was happening. So let's talk about the core zero trust components now. So the first thing is an identity-aware proxy. And this is a security service that sits between users and your internal apps. This is something that is hosted at your network's edge, and it operates at layer 7, so you have access to everything about the requests at that point. Whereas something like a VPN is at a lower layer, I think typically 3 or 4. There can be lower ones too based on, I think, IPs maybe, but let's just take a quick look at the diagram here just to go through things. So the identity-aware proxy is the big rectangle there, and you have somebody from the internet trying to access something. They say, I want to go to the protective service, which is in your internal network. In between that is the identity-aware proxy, and there's a few things here. So when you first go and access something, it's going to go, are you logged in? So you're not logged in. You're going to get redirected to an identity provider. That could be like Google, GitHub, could be a custom one for your work, but an identity provider. And then once you get logged in, the proxy is going to go, okay, you're logged in, but let's go check your policies now. Are you allowed to board this plane at this time as a pilot, for example? And the policy is always evaluating. And as you make literally every request, it checks these things every time. It's not just like I logged into the web app and then you're considered trusted. The next request you make, it's going to do those checks again. Just going to take a sip of water. This Peloton class is making me thirsty. Cool. So let's just talk about context-defined access. So like I was alluding to, zero trust is not just about your identity. It's about context. And so there's the first part, like who, which is your identity, your role. So like, for example, at the airport, your pilot ID or your boarding pass. And that's the same thing as if we make the parallel to an actual app, but maybe you're an admin or a regular user. There's also like, what resource are you trying to access? So this is the route you're trying to access that the policy engine and the rest of the identity-aware proxy is trying to get you to. And that could be like trying to get on the plane or maybe even getting into the cockpit of the plane. And again, if we do the parallel to an actual app, that's like accessing the app or accessing certain admin stuff or higher privilege things. There's also the location. If you're at the airport, you can't just go to any gate. You're assigned a gate on your boarding pass. It could change, but this is the same thing as like you're trying to access a corporate office versus a coffee shop, maybe. There's also your device, alluded to that. Daniel's on his smartphone trying to access prod from, who knows, Bali on the beach. What's going on there? And it ties into, are you on a work device versus personal? And then there's also like time. I'm on this flight. I'm on this gate with this particular airline, but my flight isn't now, so I can't get on. And this is the same thing with like business hours versus off hours, or maybe there's maintenance. And aside from that, there's behavior. So you might be wondering, like, a combination of all those things, like, why is this person logging in from here, trying to access this thing, even though it says they're logged in? You just look for unusual patterns. Like I was saying before, so you're at the airport and someone with a pilot's ID is trying to enter the cockpit using off hours at a gate where the plane isn't scheduled. That is definitely sus or suspect, as sus as the cool kids say, but I am not Gen Z. And the same thing could be suspicious context in the real world. You're an engineer accessing the production database at 3 a.m. from an unrecognized device in a foreign country. That might not check out. I alluded to the policy engine before, but we'll go through this again, and we'll just keep doing parallels with the airport and airport security. So if your gate changes, that means your access permissions has changed. You can no longer access this app. You can maybe access another one. There could be maintenance windows. I was on a flight recently and the plane just had maintenance issues, so I couldn't get on the plane yet. So you get temporary access restrictions. And other things like maybe a security incident's going on in the airport. Could be the same thing in your apps or your network. There's elevated verification requirements. And just doing a time check here. So this literally happened to me last week. I was at All Things Open AI. It was a week and a half ago. And my flight was first canceled and then it was like rescheduled and then I woke up and then my gate changed, the time changed. It's like these things really happen. And this is like the same parallel of having access to a certain app versus another one, or you can't access it at a certain time because you're only allowed in a certain time range, like having access to production database. If you're like on call, Daniel was talking in his talk about half hour ago about chaos engineering and PagerDuty and incident responses. So you could probably have a policy wired up to like your whole on-call schedule, and that would be a neat thing to integrate. I think we might be doing some collab on that at some point, but anyways. The list goes on, weather emergency, flight is canceled, crew change, you get the idea, I think. And in the zero trust equivalent, I won't read through all these, but it's what I've been mentioning throughout here. Team changes, security incidents, etc. Now, one of the cool things about zero trust is you can get micro segmentation happening. And that means like you can literally at the route level decide, what's going on and who has access to it. And so, for example, public concourse in the airport, that's like just public facing services. Everybody can access that route. The boarding areas, only certain people. Individual planes, only certain people have access to certain applications. Access to the cockpit, like I was saying, some privileged access management there. And basically this creates security boundaries around individual resources. And it also prevents lateral movement within your internal network. And this is something that VPNs can't do, like perimeter-based security. There are next-gen VPNs that can do like network segmentation. I'm still new to this, but it's still not granular enough. You can't literally say this specific endpoint. So that's a key feature of zero trust, which I think is pretty cool. And again, just you always want to go with security with the least privileged access principle. So you can do that with zero trust, very granular. And people are still going to try and attack your stuff, but I think it will genuinely make it a lot more difficult. And okay, cool. We got like a minute here, but I think we can cover all this. So I'll talk about benefits of legacy applications. So you might have a bunch of stuff, basic authentication. Maybe some apps don't even have authentication. No multi-factor, maybe limited logging, and it's vulnerable to lateral movement because there's nothing in front of it, and you're on, say, a perimeter-based security. You can immediately increase your security posture just by putting zero trust in front of these things. There is a migration path too, like the basic auth app that you might have. When you first put it in front of it, you'll get all the benefits of zero trust, but once you hit that actual app, you'll still have to log in with the old way. But that's stuff you can migrate after. But like literally just putting it in front of your existing legacy applications, that alone, you just get a huge benefit. You get uniform security immediately. And okay, I'm probably going to go over about a minute, but this is just like an implementation path. I haven't set timelines to any of this, but it's just what you could potentially do. So just do an audit of what you have going on there, document your current access patterns, do an inventory of your security controls. And the one thing I'll say is zero trust can actually initially coexist with current security infrastructure. So even if you can't move off of perimeter-based security for whatever reason, there's nothing stopping you from actually adding zero trust. So anything that's behind your identity-aware proxy, even though the rest of the network can have lateral movement, anything in front of that identity-aware proxy will be a lot more secure. Pilot it. You could start with a single app, do some basic verification, limited group of people, and then you can just layer zero trust alongside with the existing security like I mentioned. Then you can just keep expanding, add more context, more policies, extend it to more apps, etc. And then the maturity phase is just maybe you'll replace perimeter-based security completely at some point, but even if you can't, like I was saying, just having zero trust identity-aware proxy in part of your network or all of your network, even with the VPN, is still really beneficial. So they can definitely coexist. Yeah, and you get just a lot of uniform stuff happening in terms of policies and authentication, Auth Auth, all that stuff, all that good stuff. Anybody heading to KubeCon? Cool. I'm very new to Kubernetes. I was actually telling somebody just before this, my experience with Kubernetes is just restarting pods. So I am very new to Kubernetes, but Zero Trust plays really well with Kubernetes because Layer 7, you can actually secure your API control plane, pod-to-pod communication. You get consistent identity across your cluster boundaries, and also authentication without network-level trust. These are, again, super fresh to Kubernetes, so if anybody wants to school me on Kubernetes, I'm happy to listen. And I'll just go over the key takeaways, and we'll wrap up, and we should have a few minutes for questions. So I think hopefully it's intuitive now based on what I've been talking about with the airport security. I found it for myself, it was a really good way for me to understand these concepts. And just remember, it's context, not location, so not network. It's really everything about you and what you're doing and what you have access to. And check access every time. Incrementally adopt if you want to. Evolve your security around zero trust. And again, like I said, it could coexist with perimeter-based security if you really can't remove perimeter-based security. And yeah, that's pretty much it. There's some resources you can check out. Here's the slide deck if anybody wants to grab a snap of that. I think they'll be available after anyways. But aside from that, thanks everybody. And we got 2 minutes for questions.